Estimate the sixth root of 2 up to 8 decimal places. The sixth root of 2 can be rewritten as 2 to the power 1 over 6. To estimate the sixth root of 2 is to solve the equation x to the 6 equals 2. If we solve this equation, we would raise both sides of the equation to the power 1 over 6, which is the reciprocal of the power 6. Whatever we do on the left-hand side, we do on the right-hand side. 6 raised to the 1 over 6 cancelled out. The left-hand side is now x, and the right-hand side is 2 to the power 1 over 6, which is the sixth root of 2. We will use calculus, specifically Newton's method, to approximate this exact number, the sixth root of 2, which is an irrational number, up to 8 decimal places. And to do that, we zero out the equation. The equation that we have in this case is x to the 6 equal 2. To zero it out is to move everything to the left-hand side and set it equal to 0. We then let the left-hand side be the function f of x equals x to the 6 minus 2. This is a continuous function and differentiable. Using Newton's method, first, we estimate a number that is close to the supposed solution. We have an idea where the solution might be. The sixth root of 2 is a number between 1 and 2. So we will make our first initial guess that x sub 0 equals 1. This is not a solution, not yet, but it is a number that is close to the sixth root of 2. We then find the derivative of the function. If f of x is x to the 6 minus 2, then f prime of x is 6x to the 5th. Newton's method states that x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. At any step, we can use the previous guess to find the next x values. These x values, if these are conversion to a finite number, then it will be the solution. Before we plug in the numbers, we should come up with the formula for x sub n plus 1 in general for this particular problem. X sub n plus 1 is x sub n minus f of x sub n, but f of x is x to the 6 minus 2. Plugged in x sub n into f of x, we will have x sub n to the 6th power minus 2 over f prime of x sub n. Plugging x sub n to f prime of x, we have 6 x sub n to the 5th. So this is the formula for the sequence of number x sub n plus 1. We start with our first initial guess, which is x sub 0 equals 1. When n equals 0, x sub n plus 1 is x sub 0 plus 1, or simply x sub 1. X sub 1 is x sub 0 minus f of x sub 0 over f prime of x sub 0. But we already have the general formula for x sub n plus 1. X sub 1 is x sub 0 minus x sub 0 to the 6th power minus 2 over 6 times x sub 0 to the 5th power. But what is x sub 0? We guess that x sub 0 is 1. We plugged 1 into x sub 0. Everywhere we see an x sub 0, we replace it with 1. 1 minus 1 to the 6th power minus 2 over 6 times 1 to the 5th power. 1 minus the numerator, 1 to the 6 is 1. 1 minus 2 is negative 1 over 6 times 1 to the 5th is 1. So 6 times 1 is 6. This is 1 plus 1 over 6 or 7 over 6. If this is a short fraction, we should write the exact fraction. If not, we should round one more than the required decimal places. The final answer in this case needs to have 8 decimal places, so we should round it to 9, at least 9 decimal places in the intermediate step. But 7 over 6 is a short fraction, so we will keep the exact form for now. X sub 1 is 7 over 6. We then use x sub 1 to find x sub 2 using the same formula that we obtained earlier. X sub 2 is therefore x sub 1 minus x sub 1 to the 6th power minus 2 over 6 times x sub 1 to the 5th. But x sub 1 is 7 over 6 minus, we replace x sub 1 with 7 over 6 over 6 times 7 over 6 to the 5th. In the exact fraction, this is 681557 over 605052, which is not a short fraction, so we will round it to 9 decimal places. 1.126443677. This is x sub 2. We then use x sub 2 to find x sub 3. X sub 3 is x sub 2 minus x sub 2 to the 6 minus 2 over 6 times x sub 2 to the 5th. But x sub 2 is 1.126443677 minus, substitute x sub 2 into this formula, 1.126443677 to the 6th power minus 2 over 6 times 1.126443677 to the 5th power. You should use a graphing calculator or decimal to do these computations. These are not meant to do by hand. Again, use a calculator to speed this up. Put this in the calculator. With 9 decimal places, we obtained 1.122497067. Again, rounded to 9 decimal places because the final answer requires that we have 8 decimal places. This is x sub 3. We then use this x sub 3 to find x sub 4. X sub 4 is x sub 3 minus x sub 3 to the 6 minus 2 over 6 times x sub 3 to the 5th. And this is 1.122497067 minus 1.122497067 to the 6 minus 2 over 6 times 1.122497067 to the 5th power. And put this in the calculator, we should get 1.122462051. We know that we have not obtained the answer because the number of decimal places do not match. If we were to round it to 4 decimal places, we will stop right here because x sub 3 rounded to 4 decimal places would give us 1.1225. X sub 4 rounded to 4 decimal places would give us 1.1225 as well. But again, in this case, we want the decimal to match up to 8 decimal places, so we have to keep going. X sub 5 is x sub 4 minus x sub 4 to the 6 minus 2 over 6 times x sub 4 to the 5th. But x sub 4 is 1.122462051. So we plug this into x sub 4. 1.122462051 to the 6 minus 2 over 6 times 1.122462051 to the 5th power. And we then put this in a calculator to obtain x sub 5 to be approximately 1.122462048. We have been rounding all these numbers up to 9 decimal places, but observe that if we were to round it to 8 decimal places, 1.1224620 up to 8 decimal places, x sub 5 matches x sub 4 up to 8 decimal places, 1.1224620. Since the number of decimal places match already, we stop at this point. We conclude that the solution is approximately 1.1224620 up to 8 decimal places.